Hello everyone, this is Dr. Speranza and today we're going to be working on how to solve or evaluate basic problems involving square roots. Now the first thing that I want you to understand is the square root notation. Now square root, the reason why it's called the square root is because the root of this particular radical, this is the radical, is the square or the exponent of 2. But since in mathematics we always want to simplify things, so instead of writing the little 2 in your square root, we are taking it away because it's kind of redundant because it's already called the square root, so we don't need to put the square anymore. So this is now our square root notation for mathematics. And now the square root is another example or perfect example why you need to master your multiplication table. And as I've mentioned, your multiplication table is important not just in understanding prime factorization or how to multiply numbers or how to divide numbers. It will also help you understanding the concepts that you will be learning in algebra, calculus, trigonometry, and geometry, and a lot more. So as early as now, you need to master and memorize and remember your multiplication table to be able to manipulate numbers a lot easier. Now let's say we'll have this multiplication table, and as you'll notice, we have the diagonals that is highlighted in this particular table. And the reason why it's highlighted is because we call these special numbers as perfect squares. And the reason why they are called perfect squares because when you multiply two numbers to each other and they are identical, it will equal to that number. For example, 49. 49 is a perfect square because 7 times 7 is equal to 49. And that is the reason why it's called a perfect square. So as the other numbers in your diagonals like 1, 4, 9, 16, all the way to 225, which is what we are seeing right now in our multiplication table. Now, what is the importance of the perfect squares in your square roots? The square root symbol is basically an operation or math operation that is asking you to simplify a perfect square into its square root. And in this case, 9, if we factor out 9, its factors would be 3 and 3. And we know that if we take the square root of a certain number, we're basically simplifying the perfect square, representing it with just that common number, which is in this case 3. That's why all perfect squares, like square root of 64, if we factor it out, will give you 8 and 8. So therefore, your square root of 64 is equal to 8. And this is basically how the concept of square roots and how you solve square roots is playing in your little symbol like so. So if you have square root of 100, if you know your multiplication table really well, you know that 100 is a perfect square because 10 times 10 is equal to 100. Therefore, we have a square root of 100 which is equal to 10, just like square root of 1. And square root of 1 is going to be a factors of 1 and 1, and we know that 1 is also a perfect square, and we could say that the smallest positive perfect square in our natural number would be 1 because 1 times 1 is equal to 1, so the square root of 1 is equal to 1. Now what if we have the square root of 2? And if you're going to look at your multiplication table, square root of 2 is not a perfect square because it's not in your diagonal. And also, 2 is a prime number. Therefore, if there is no, if you are taking the square root of a number that is not a perfect square, you can simply just write it as square root of 2 because you can no longer simplify this particular number unless you have a calculator. And that's the only time that you will be working with a calculator with numbers such as 2, 3, or prime numbers inside the square root. But in mathematics, since we don't have a calculator right now, we're just going to leave it as the square root of 2, and that is an acceptable value to represent the square root of 2 in a math problem. Now, what if we encounter problem similar to this one, square root of 12. And we know that 12 is not a perfect square because there's no factors that's identical that when you multiply to each other will equal to 12. However, there are certain numbers in our multiplication table that we can factor out and we can produce factors of a perfect square, just like 12. Although 12 has a factor of 12 and 1, 6 and 2, and 3 and 4, we'll choose 3 and 4 as a factor of 12 because 4 is a special case of number which is a perfect square. And if we separate the two square roots, because we have a property of square roots wherein if you have square root of 4 times 3, we can separate it into square root of 4 and square root of 3. And we know that the square root of 4 is 2, and 3 is a prime number, so we'll just leave it as square root of 3, just like the square root of 2. So if we're going to further simplify this, we'll have 2 square root of 3. And this is one way of figuring out the square root of some numbers. So this is basically square root of a number level 2. So if you have a non-perfect squares, you can produce a factor, or sometimes you can produce factors of that number that is a perfect square. So let's take a look at these numbers that we are going to evaluate. So we have square root of 50 all the way to square root of 30. And what we're going to do is to exercise our mastery of the multiplication table by thinking of a factor of those numbers that has a pair of a perfect square and a regular number. So for example, 50, we know that we don't have a square root of 50 because 50 is not a perfect square. But if we separate it and find its factors, we know that 25 and 2 is equal to 50 when you multiply them up. And we know that 25 is a perfect square, so square root of 25 is 5. And the square root of 2 is just a square root of 2 because it's not a perfect square or a prime number. So for square root of 50, we have 5 square root of 2. Just like with square root of 18, you need to think of a pair of numbers. One should be a perfect square and one is just a regular number. And in this case, square root of 18 is 9 and 2. So 9 is a perfect square, and we can simplify it into square root of 9, which is 3. So square root of 18 is equal to 3 square root of 2. And square root of 27, on the other hand, is also factorable with a perfect square, and that would be 9 and 3. So if you separate the two factors, we'll have the square root of 9 and the square root of 3, and we know that square root of 9 is just 3, so this is 3 square root of 3. And for square root of 28, factors of 28 that has a perfect square is 4 and 7, and 4 times 7 is 28, but 4 is a perfect square that is what we need to simplify square root of 28. And we'll have 2 square root of 7 for problem number 4. Now for the last item that we have here, we have square root of 30. And if you're going to think of factors of 30 that has a perfect square, you'd probably quit, which is normal because there's no factors of 30 that has a perfect square. The factors of 30 would be 30 and 1 and 15 and 2, and that's it. So 15 is not a perfect square and 2 is not a perfect square. So in this case, it's just going to be square root of 30 because just like what we had a while ago, not all numbers are perfect squares. And at the same case, not all numbers has a factor that has a perfect squares. And when that happens, we'll just leave it as square root of 30. And this is why it's important that you know your multiplication table really well to be able to understand a lot of math problems and how it works when you visualize it in your head using something that you already know. And again, this is Dr. Esperanza, and thank you for watching, and see you again next time.